We've been talking about how you can think about the web as a network and how that gives us a global structure that we can look at. But the next step is to think about how we can use that network structure to actually find information on the web through search. Now, search is something we do many, many times a day. Whenever you type a query into Google or when you look up people, you look up products, news, reviews, recommendations, opinions, advice, videos with how-to lessons, entertainment, all of those are things that we go online and we search for. And when you type a query into Google or other search engines like Bing, you're actually using a technology that grew out of the field of information retrieval, a field that reaches back to the 1950s and 1960s and has thought for a long time about how to organize information and make it accessible to people. Now, when the field of information retrieval first started out, it was really targeted at a relatively thin slice of society. Professionals whose jobs consisted of searching for a living, reference librarians, patent attorneys, people who needed to look things up regularly. And ordinary people really didn't actually search very much. And in a sense, if we fast forward from the 50s and 60s to the present day, it really would have been hard for those people, those researchers, to imagine how much the act of searching has entered the lives of each and every one of us. And yet, when we search, when we go on Google and we search for something, we're following a kind of pipeline that really was articulated back in the early days of information retrieval. It begins with a person who needs some information, right? They have an information need. They want to know the name of a restaurant that they're thinking of. They want to look up reviews for a product, and they turn that information need into a query, right? So we can sort of think about it as from the person, we end up with a query. And then the query gets passed to a search algorithm, something that takes the available information, say the web in this case, and takes the query and turns it into a set of results. Now, the results could be a bunch of things. On a search engine, we often think of them as a list of links to click on. Here are some web pages that might be relevant to your query. But they could be a bunch of other things. They could be a set of reviews. They could be a set of dots on a map. They could be a set of photos of people. There are a whole bunch of possible things that the search results could be. Of course, the results of the search aren't the actual endpoint. Remember, the person had an information need because they needed to accomplish something. And so in the last step, the person actually selects among these results and uses that selection to go and accomplish their task. So that's basically a picture of what the search process looks like schematically. And even today, when people go online to search, this is roughly what they're doing. And yet, in other ways, the web presents problems that are very, very different from sort of the classical setting of information retrieval, right? So classical information retrieval, when it was a reference librarian or a patent attorney, what they were doing was really going into a collection of documents that was very controlled, right? So a patent attorney is looking at a set of US patents maybe, and the patents are written in a certain style. They have certain keywords, certain annotations, and the attorney searching has been trained how to search. When we go on the web, all of those assumptions get exploded. First of all, everyone involved is now an amateur, typically. The people writing the pages have not been trained how to author documents to make them easy to find. The people searching are just you and me, just typing stuff into a search box. Second is the issue of scale, where once upon a time, the collection was big, maybe it had millions of documents, but it was still relatively controlled. Now we have systems that are handling billions of web pages and processing billions of queries every single day. So we have to think about how this works at that enormously large scale. Third is the highly dynamic nature of it, right? When you went to search a collection of scientific articles or patents or things like that, it was a collection that was relatively static. Now the information is changing very rapidly. And what's more, it's actually responding to how it's being ranked. That's the point we're going to come back to. But the existence of search algorithms and their ubiquity means that people actually author their web content thinking about how it's going to be found through search. And there's a fourth point, and this is the one that we're going to zero in on here, what I'll call the problem of abundance. Once upon a time, people thought about information retrieval as really looking like a sort of needle in a haystack activity. I'm trying to find a patent that has to do with fuzzy logic controllers for air conditioning systems, and maybe there's like one patent that's going to do that, or maybe there is zero. And it's up to me to find that target. But now, I'm searching online, I go online, I want to find out, maybe I'm applying to college, and I want to find out about Cornell University. So I go to the search box and I type Cornell. Now the problem is, this is no longer a needle in a haystack query. There are millions of pages that are completely good answers for the query Cornell. And the question is, you as a user are not going to be able to sit through a million results and read through them, the search engine has to figure out which one do you want. And the problem, and this gets back to this new world in which everybody is a searcher and everyone is an author, when someone goes to the search box and they type Cornell, they're giving the search engine one word to go on. That is really not a lot of information. And the search engine has to try to figure out, what do they want, right? Do they want Cornell University's homepage? Do they want the Wikipedia entry for Cornell, Cornell University Athletics, the Lab of Ornithology, which studies birds? Do they want something different like Cornell College, which is in Iowa and not in Ithaca, New York? So how can we possibly figure this out? We have one word to go on, and we're trying to guess what you want. And one insight here is that, suppose, for example, as appears to be the case, most people want cornell.edu, the homepage of Cornell University in Ithaca, New York, when they type this word in. Well, the problem is, if I just look at that page, yeah, it says Cornell, it's got the logo, it kind of has this, red theme and everything, but it doesn't really say the word Cornell more than other pages, and it doesn't seem to, there's nothing really on the page itself that actually tells me that this is the page that you want. The real way to figure that out is to look elsewhere on the web, to see how everyone else talks about Cornell, and to see what they point to. In other words, the real thing that makes cornell.edu the arguably best answer for the query Cornell is what the rest of the web says about it. When people at random places on the web say Cornell and link to something, it's very often Cornell's homepage. In other words, we're effectively going to let the web vote. We're going to use the links on the web, and this is the point where network structure comes in. We're going to use links to try to find the page that we want. So one way we could imagine doing this would be to do a search just on the word Cornell, collect a whole bunch of things that say Cornell, a whole bunch of pages, and now look at what they point to. And one thing we could do is say, among the sample, the page that gets pointed to the most is going to be our guess for the best answer, because it in effect is the one that is the most endorsed by a broad sample of pages that are relevant to the query Cornell. Okay? And that's a first hint at how we could begin to use links to actually start to address the search problem. Rather than look at a page in isolation, let's try to understand the information on the page by the way it is linked from the rest of the web, by the way it's embedded in the network that the web represents. But you should step back and ask, is voting really all that we can do? Surely there must be other more subtle patterns hiding there in the links. And in fact, there are. We can actually look much more deeply into the network structure and get more out of it. But in order to do that, we're going to have to think more broadly about what the network is actually telling us.